When I wrote the Kalam cosmological argument, I interpreted this initial singularity, this point of infinite density, infinite space-time curvature, as a mathematical idealization, and therefore not a physical state of affairs. And that is, in fact, the way most physicists take it. They would say this boundary point to space-time is not a physical entity, it's a mathematical idealization, and that's why it's equivalent to nothing. It's not an actual physical thing that exists. But as I came to see in my discussions with Quentin Smith, if you do take the initial singularity to be the first physical state of reality to be real, well then the question simply arises, where did it come from? It isn't eternal in the past. It hasn't always existed. It's ephemeral. It ceases to exist as soon as it comes into being. And so the question then would simply be, how do you explain the origin of the singularity? I notice, though, that Quentin has in fact changed his mind. He's come around to my point of view of regarding the singularity as simply a mathematical idealization. It's not really a physical state of affairs. But either way you take it, the argument would still say that you need an explanation of why the origin of the universe came to be.
Should we begin to use a different terminology than something's being infinitely dense? What do we mean?
Well, that's part of the scientific terminology. You just need to understand that when mathematical physicists use terminology like that they're talking about a mathematical idealization. This occurs often in science. For example, talk about a frictionless plane or an ideal gas that's composed of point particles like a continuum. There really are no such things as a frictionless plane, or talking about something, say, that is infinitely distant in the universe. These are mathematical idealizations and need to be understood as such rather than to be interpreted as physical, literal states of affairs.